Small a is an element of a capital set A, then it is denoted as A belongs to A. First one is the roster, or it is also called as the tabular form, and the second one is called as the set builder form. What are the solutions for this? X square plus x minus 2, this is a quadratic equation. The first one is a null set, or it is also called as an empty set, or it is also called as a void set. Hello dear students, welcome to this session of Mathematical and Statistical Computing class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. So in my previous class, we have discussed regarding the first part in Unit 1, that is Mathematical Logic. Now, in this session, I am going to discuss regarding second part of the Unit 1, that is set theory. So this is second part in first unit, that is set theory. First part is mathematical logic and the second part is the set theory. So today in this session I am going to discuss regarding definition of a set, examples, types of sets and example for types of sets, and few problems related to the types of sets. Now let us know regarding what is a set. Set, the definition of a set. Set is nothing but the collection of well-defined objects. So a set is a collection of well-defined objects. So the objects may be, whatever may be the objects, it must be well-defined. So a set is a collection of well-defined objects. For example, players of a cricket team. The players of a cricket team is the collection of cricket players is a set. Again, students in your school, the number of students in our school is again a set. Members of your family, all the members of your family is also a set because it's a collection of well-defined objects. Vowels in English alphabet. So the vowels in English alphabet is A, E, I, O, U. So it is also a set. Prime factors of 10. So the prime factors of 10 are 2 and 5. 2 and 5 are the prime factors. It is a set. Again, odd natural numbers less than 8. So all the natural numbers which are less than 8 and they are odd, that means all odd natural numbers less than 8 is 1, 3, 5, 7. This is also a example for a set. Similarly, numbers in a dice. So you might have been observed a die contains 6 faces, that is 1, 2, 3, 4, 5, 6. So it is also a well-defined object. So number of faces, number of numbers in a dice is 1, 2, 3, 4, 5, 6. These are all few examples for a set. That means a set is a collection of well-defined objects. The objects may be numbers or alphabets or whatever it may be, it must be a well-defined. Now, sets, for example, the important sets in mathematics. The important set we are going to discuss in mathematics usually are the set of natural numbers denoted as n. The set of natural numbers is denoted as n, which contains all the counting numbers. So n contains 1, 2, 3, 4, 5, etc. So this is called a set of natural number. Similarly, the set of integers. The set of integers is denoted as z or I. I or z is the representation of set of integer which contains 0 as well as all positive and negative numbers. Right. So the set of integers is denoted as I or z, which contains 0 and all positive and negative numbers. Now, the set of rational numbers is denoted as q, and the rational numbers of the form p by q such that p and q belongs to any integer, positive integer or negative integer, whereas denominator q is not equal to 0. For example, 1 by 2, 1 by 3, 1 by 4, etc. These all comes under the set of rational numbers. Right. Now, the set of real numbers. The set of real numbers is denoted as R is the set of real numbers. Right. These are few sets which we are going to study in mathematics. The set of natural numbers denoted as n, the set of integers z or I, and the set of rational numbers q, right, the set of real numbers as R. Now, so some conventions in set. What are the convention theory in sets? So, the important conventions in sets are usually denoted by the capital letters like capital A, capital B, capital C, or some capital letters like X, Y and Z, etc. So, usually a set is represented by a capital letter like A, B, C, X, Y, Z, etc. And the elements of the set are represented by the small letters like small a, b, c, d and etc. So, the set is represented by capital A, capital B, capital C, capital letters, whereas the elements of the sets are represented by the small letters A, B, C and D. If A is an element of a set A, capital A, we can write this as A belongs to A. That means, if A, small a is an element of a capital set A, then it is denoted as A belongs to A. And how to read it as? This can be read it as A belongs to A, small a belongs to A. If A is an element of a set capital A, then we can represent it as A belongs to A and read it as A belongs to A. If B is not an element of a set, then it is denoted as B does not belongs to A. B does not belongs to and it is read it as does not belongs to A. How to read? B does not belongs to A. So, if any element belongs to the set, we are going to represent it as E, epsilon, and does not belongs to means this is does not belongs to, right? Now, example, if V is a set of vowels, A and B are alphabets, then A belongs to V, but B does not belongs to V. See, if V is the set of vowels, V is a set of vowels. Vowels means A, E, I, O, U. Then here A belongs to V because A is a vowel, whereas B does not belongs to V. That is not a vowel, it is a consonant. So, similarly, P is the set of prime factors of 30, then 3 belongs to P, but 15 does not belongs to P because the prime factors of 30 is 3. 3 is a prime factor, whereas 15 is not the prime factor. Now, the next concept is the representation of a set. So, how to represent a set? A set is represented in two forms. There are two methods to represent a set. First one is the roster, or it is also called as the tabular form, and the second one is called as the set builder form. So, there are two methods to represent a set. The first method is the roster or tabular method, and the second method is called the set builder form. Now, let me discuss what is this roster form or tabular form with an example. Now, the roster form. In roster form, all the elements of a set are listed. Just we are going to list all the elements of a set, and these elements being separated by the commas and enclosed between the two flower braces like this. So, in the roster form of a set, all the elements of the set are listed and they are separated by a comma and they are enclosed between the two braces, two flower brackets like this. For example, the set of letters forming the word school, S-C-H-O-O-L. So, that is S-C-H-O-L, S, comma, C-H-O-L. Similarly, let us take the set of vowels. The set of vowels are nothing but A, E, I, O, U. So, this is how we are going to represent a set. This type of representation is called as the roster form. That means here the elements are separated by a comma and they are enclosed between the two flower brackets, right? The second one is called the set builder form. In set builder form, all the elements of a set possess a single common property which is not possessed by any element outside the set. That means here the elements of the set are arranged according to a proper definition. All the elements will possess a single property. That is, all the elements of a set possess a single common property which is not possessed by any element outside the set. For example, let us consider for example x such that x is a natural number and which lies between 3 and 10, 3 less than x less than 10. The set of all natural numbers which lies between 3 and 10. So, is read it as the set of all x such that x is a natural number and x lies between 3 and 10. So, what are the numbers which lies between 3 and 10? So, 4, 5, 6, 7, 8 and 9 are the elements of the set A. So that is denoted as A is equal to A contains 4, 5, 6, 7, 8 and 9. This is how we are going to represent the elements of a set using set builder form. This will possess only a single property. What is that property? All the elements of X lies between 3 and 10. The natural numbers which lies between 3 and 10. That is 3 and 10 is 4, 5, 6, 7, 8 and 9. Right. Now move on to the second example. Now these are few definitions and the methods to construct a set. Now let us take a few examples. So let us discuss few problems. So usually you may expect this type of question for 2 marks. Now what is the problem given? Write the set X such that X is a positive integer and X less than 4 in the roster form. Just we have to write a set A such that X is a positive integer and less than 4. Positive integers means 1, 2 and 3 are the positive integers which are less than 4. So X A is equal to 1, 2 and 3. Move on to the second example. What is the second example? Write the set A. A is equal to 1, 4, 9, 16, 25, etc. in set builder form. Here the elements of the set are in the form a square of a natural number. Observe carefully. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. That means it is a square of a natural number. So therefore we can write like this. A is equal to a set X such that X is a square of a natural number. Right. That's it. Or if you want, you can also write like this. Or A is equal to X such that X is equal to n square where n belongs to a natural number. X is equal to n square such that where n belongs to a natural number. So if you take n is equal to 1, 1 square is 1, n is equal to 2, 2 square is 4, n is equal to 3, 3 square is 9, n is equal to 4, 4 square is 16. If you put n is equal to 5, 5 square is 25, etc. This is how we are going to represent in the roster form. Now, set builder form. Write the solution of the set of the equation x square plus x minus 2 is equal to 0 in roster form. Now, how to represent this in the roster form? Now, just solve this. What are the solutions for this? X square plus x minus 2. This is a quadratic equation. Factorize it, cross multiply it. So this is x into x square, 1 into 2 is 2. So this can be written as plus into minus it is minus. The factors are x plus 2 into x minus 1 is equal to 0. X plus 2 is equal to 0 or x minus 1 is equal to 0. X is equal to minus 2 or x is equal to plus 1. Write the solution set of the equation x square plus x minus 2 is equal to 0 in the roster form. So just first find out the factors for this. The factors are minus 2 and plus 1, right? So therefore the solution set A is equal to, what are the factors? So minus 2 comma plus 1. This is the solution. Now move on to the next problem. Write the following set in the roster form. So we have to write the following sets in the roster form. There are 4 sets represent in the roster form, right? Now first one, let us take first one. What is the first one? A, x such that x is an integer and lies between minus 3 and plus 7. So here the elements which lies between minus 3 means minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. That's all. So these are the elements of the set A. The values which lies between minus 3 and plus 7 are minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. Now what is the second one? Here B is x such that x is a natural number less than 6. A natural number less than 6 means 1, 2, 3, 4, 5. That's it. Natural numbers less than 6 is 1, 2, 3, 4, 5, 6. So the prime numbers which divide 60 are C is equal to, you can divide by 2, again you can divide by 3 and 5. So if you divide 60 by 2, even you can divide 60 by 3, and even you can divide 60 by 5. So these are the prime numbers which divide 60. Now, last, the fourth one, D. The set of all letters of the word. So the set of all letters of the word. So what is that? Fourth question. D is equal to B, comma, E, comma, T. T is repeated, E is also repeated, take R. That's it. So B, E, T, R. Okay. So the letters are nothing but B, E, T and R. Just avoid the repetition. That's it. So this is how we are going to solve this problem. Move on to the types of set. The first one is a null set, or it is also called as an empty set, or it is also called as a void set. Null set, empty, or a void set. So usually you may expect this type of question for 2 marks. Now, what is a null set? A set which does not contain any element is called a empty set or a null set, or it is also called as a void set. A set which does not contain any element is called a null set or a void set. The empty set is denoted by the symbol like this. This is the representation of a null set, or even we can write just flower brackets like this. Now, for example, let us take an example. If A is equal, if x such that 5 less than x less than 6, all the values which are natural numbers lies between 5 and 6. 5 and there are no natural numbers between 5 and 6, right? So therefore, this is an example for a null set. So this is a null set. All the natural numbers which lies between 5 and 6 is an example for a null set. Similarly, let us take one more example. B, the set of odd natural numbers divisible by 2. So set of odd natural numbers divisible by 2 is also an example for a null set. Singleton set. Singleton means the name itself indicates a set which contains only one element. A set which contains only one element is called the singleton set. For example, the set of even prime numbers. Even prime number is 2. 2 is only the even prime number. So this is an example for a single set, right? Singleton set. So 2 is only the even prime number. Therefore, this is an example for a singleton set which contains only one element. Another example, Bx such that x belongs to n and x square is equal to 25. X belongs to 25. X belongs to n. X square is equal to 25 means the factors x is equal to square root of 25 means plus or minus 5. But here x belongs to n. X belongs to n means x is equal to only the positive number, that is 5. So b is equal to 5 is an example for a singleton set. Right. Now, let us know regarding finite and infinite set. What is a finite set? Finite set means a set which is empty or consisting of a definite number of elements is called a finite set. A set which is empty or it contains a finite number of elements, then it is called a finite set. Otherwise, the set is called an infinite set. A set which contains finite number of elements is called a finite set. If it contains infinite number of elements, then it is called an infinite set. Now, examples, let W set of days in the week, that is a finite set. So, in a week, we have 7 days, Sunday, Monday, Tuesday, Wednesday. So, therefore, it is a finite, it contains finite number of days. The set, let G be the set of points on a line. This is an infinite. So, there are infinite number of points on a line. So, the set B is the set of months in a year. This is a finite set. Similarly, let P be the set of all prime numbers. Then prime numbers are infinite prime numbers. So, suppose if A is equal to 1, 2, 3, 4. This contains 4 elements. This is an example for a finite set. If I write this, B is equal to 1, 2, the set of natural numbers, etc. This is an infinite set, right? So, here the number of elements are 4, whereas in the set B, the number of elements are infinite. So, therefore, these two are example for a finite and an infinite set. Now, equal sets. What are equal sets? Two sets A and B are said to be equal if they have exactly the same elements. Two sets are said to be equal if they have exactly the same elements. So, we can denote this as A is equal to B. Otherwise, the sets are said to be unequal not equal, then denoted as A is not equal to B. If the two sets having the exactly same number of elements and same type of elements, then they are called equal set, otherwise they are not equal. Example, let A is equal to 1, 2, 3, 4, B is equal to 3, 1, 4, 2, but it contains same 1, 2, 3, 4, therefore A and B are same, they are equal sets. The number of elements in A is 4 and the number of elements in B is also 4, and A contains 1, 2, 3, 4, B also contains 1, 2, 3, 4, same number of elements and same elements are there in both the sets A and B, they are equal. Now, whereas in second example, let C is equal to 1, 2, 3, 4 and D is equal to 1, 2, 3, 5. This is not equal because here, so this is an extra element. So, here in D we have 5 which belongs to D, whereas here 5 does not belongs to C. So, therefore, these two sets are not equal. The number of elements in set C is 4 and number of elements in set D is also 4. In set C, 5 is not included, whereas in set D, 4 is not included. Therefore, they are not equal. So, denoted as set C is not equal to set D. This is how we are going to represent whether the sets are equal or not. So, hope you got an idea regarding equal sets. These are few types of sets. So, that is, so far we have discussed regarding definition of a set and representation of a set and different types of sets. So, that's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.